Thank you very much. Let's just dive straight in. I have some code on the screen. What's wrong with it? There could be many things, but we'll start with hopefully the obvious stuff. Go for it. Yes, exactly. That was the one I was hoping for. Yeah, if this insert doesn't work, then we never manage to call the close. We create this resource, we create this database connection, we use it, it doesn't work, and then we never clean it up. And this is a problem. This is a thing we run into, and we want to avoid it. We do have a tool for avoiding this, which is try finally, which allows us to wrap code and handle exceptions, or just generally handle any case where we leave this block. And this works, but there is a new proposal. Well, it's not even a new proposal anymore. There is a proposal that is very close to finally coming out in browsers and in Node. And I wanted to talk about that and talk about how, not just what it looks like, but also how we've found it useful specifically. So yeah, it is using, this is the magic syntax, the magic keyword, and I want to, before we get into the details of this syntax, I think we need to formalize what we're talking about when we're talking about resources. Like, when we have this database connection, what is it about it that makes it difficult to deal with this, in this case, what makes it unique? And this is this idea that we need to close it in some way. And currently there are lots of different ways to close different resources. Some things, like subscriptions, we might unsubscribe them. We have intervals and timeouts where we need to clear them. There's lots of different ways to do this. And this works currently because you can just write whatever you need in the finally block. But we run into a problem if we want to create some sort of general syntax for this. So the solution here is we create a new magic method, as it were. We have this well-known symbol, symbol.dispose, and if an object has a function with the name symbol.dispose, it should take no arguments, it should return essentially nothing, and it should clean up that function. It essentially does the same thing that any of the other functions have been doing. Some functions, or some cases, are a little bit more complicated because some cases are asynchronous. If you have, say, a file, you want to flush things, like when you close it, you want to flush anything remaining in the buffer so you don't lose changes and things. So we also have an async version of this. And there being an async version of everything will come up a lot in this. Like, there is a lot of stuff and an async version of a lot of stuff. But yeah, so we've got the chance to close things, and this is a good start, but we want to, the thing we're trying to sort of resolve is this sort of try finally thing. This creates a new scope, this creates a new block, and it can create quite sort of complicated syntax, or it is extra syntax, and the question is, can we get rid of this syntax? And the realization that I think is important here is that if we go back to this example, we start off by creating our resource, and then we have this block where we're using it. And inside this block, we can do whatever we want with it. At the end of it, we're going to close it. And then once we leave this block, after the try finally, we really don't want to be touching the database at all because it has been closed already, and we are no longer in the safe space of this sort of try block. So we want to avoid this. The realization here, I think, that is interesting is the variable, this database connection object, the scope of the variable that it is stored in is essentially the scope that we're interested in when we're talking about when do we want this stuff to be cleaned up, when do we want to remove this. So if I skip forward, we have this using resource syntax, and what you can essentially imagine this as is an alternative to const or let. Rather than, it defines a variable, but rather than it just being a random variable, this is specifically a variable that will get cleaned up at the end of the scope when that variable is no longer usable. So at the end of your function, at the end of your block, at the end of whatever you've defined that in, it will get cleaned up. It's a little bit different. There's some specifics to the syntax. It's not quite the same as some of the other ways of declaring variable, but I think that's the best intuition for it. Of course, there has to be two of them. And we can sort of see what that might look like in practice. So here is the same function we had before. And again, we have this try finally. We see that essentially what we want to do is take whatever is in the try block and make that the main, or take that into the main scope. And we can just essentially remove the try finally stuff, because the database.close method will get called automatically once we leave this scope, whether that be something was thrown, whether that be an early return, whether that be we've reached the end of the function. Whatever it is, we know that that is going to get called. But importantly, like the rest of the scope, the rest of the space where that variable is available, we know we are in this sort of safe space that we would have had with the try block. So that, I think, is the sort of like the intuition that we can sort of build for this. This is cool. This is a nice feature. Before I do that, you can do this multiple times, like with any variable declaration, and you get the nice feature that the first thing that was created ends up being the last thing to be cleaned up. So we don't need to worry about, I've cleaned up my database connection, but the message insertion service, I came up with terrible examples here, I'm really sorry. But the message insertion service is still active. We have this sort of like almost pyramidal or stack-like cleanup system. But yeah, this is cool, this is interesting, I like it, it is useful, but is there more that we can do with this? Are there ways that we can are there patterns that we can build out of this? Are there ways we can expand this? Yes, otherwise this would be a short talk. What are those ways? The first thing I want to talk about is grouping resources with this idea of disposable stack. A disposable stack is there's two of them. A disposable stack is a stack of different resources, and we can sort of look at a bit of an example here, messing around with a bunch of different stuff. So a disposable stack is an object that we can create with a constructor, and then the first thing that we can do is use things inside this stack. And this is very similar to the using syntax, but a bit more dynamic and not bound to specific syntax or specific scopes. Instead, we say we want this resource to be managed by the stack, which means that when the stack gets disposed of, the resource will also get disposed of. And again, with how before, we have, it's literally called a stack. We have this sort of same stack effect where the first thing that we add into it will be the last thing to get cleaned up. So we can start with this. It returns the value that you pass in, which is a very convenient way of doing things with that. So this is the first way. The second thing we can do is just run a function when this stack gets cleaned up. This is useful for dealing with certain things that don't fit well with the current resource paradigm, or with the resource paradigm that the disposable system expects. It just runs a function when the stack gets disposed. It's fairly simple. We have then a combination of the two, which is this stack.adopt, which takes a resource, but that resource doesn't necessarily need to be in or have this magic method, this symbol.dispose method that we were talking about earlier. Instead, we provide essentially a dummy implement, or our own implementation of that method. We can provide an extra function in there that does the cleanup for us. And this sort of combines the two and essentially just means that you don't have sort of spare variables floating around or sort of have to put things on extra lines. It's convenient if you're working with older modules that haven't quite got these APIs yet. what I've shown you so far is basically all stuff, or is mostly all stuff that you can do with the using syntax. So why is disposable stack more interesting than that? The disposable stack is also disposable. You can use it. That's also important to remember. The disposable stack is dynamic, or allows for essentially dynamic addition of resources. So here we have a bunch of, for example, a bunch of replicas that we need to set up connections to all of them. If we tried to put a using statement where we've got const con here, then as soon as we leave each iteration of the for loop, we'd immediately close the connection. This would be completely useless, and we don't want this. So instead, we can add things to this disposable stack. We use the disposable stack as a whole thing, and then at the end of it, we can do whatever we want with our replicas or other connections that we have created. So it allows that sort of sense of dynamism. Dynamism? That doesn't feel like a real word. But yeah, it allows that dynamic capability. And the other thing that it's really useful for is sometimes you have an object or some sort of class that uses a bunch of resources, and in this situation, you don't want to manage cleaning them all up yourself, so just throw them all inside this stack and then manage cleaning up the stack itself. So in this case, we provide the async dispose magic method, this symbol method, and we just delegate to the disposable stack that we have in our class. The dispose async is a prettier way of writing async dispose specifically for the async disposable stack, and there is, of course, an equivalent for normal disposable stacks. So this allows us to essentially group resources together in a very convenient way. The next interesting thing that we can do this, and this falls out of a lot of the pattern, or falls out somewhat of what we've looked at before, I've called it the use and move maneuver. I'm not 100% sure that maneuver is spelt right there. I'm really sorry. English is meant to be my native language, but, who knows? What is the use and move maneuver? Let's look at an example of something that I like to write a lot. I'm a big fan of dependency injection, but I don't like dependency injection frameworks. So I often sort of end up writing one of these setup functions where I build up all of the different dependencies that I'm using, create all of the connections to the databases and whatever other services and systems we're using, create the services that we're going to be passing around in our code, and then return this as an object that can be used then in, say, my routes or whatever else that I'm writing. This has some problems. We are creating resources, and we are not managing them. We can do that, though, with the async disposable stack. In this case, we use them, or we create the stack, we use the resources, and we attach a dispose method then to the object that we return. And in this situation now, when a user, or when the caller calls this setup function, they now have the ability to dispose of all of the things that we have created inside this setup function. However, we have now run into the same problem that we had right at the very start that someone over here mentioned, where if an error happens somewhere while we're creating the user service, say, nothing will get disposed because right now nothing is, we aren't using this using syntax. There is we can try simply adding await using in this case, but the problem with this is that this is going to clean everything up as soon as the function returns, which means I'm going to create all of my resources, I'm going to create everything I need, I am going to return this and immediately clean it up so that nobody else can ever use them, and the function is now useless. So how do we resolve this? This is the use and move maneuver, which is, we can call this really clever method move. And what move does is it takes all of the resources that the stack knows about, it creates a new stack, a new empty stack, and it puts all of the resources in that new stack not disposing of them, letting them be like they are, and then clears them from itself. So now the resources are managed by a different stack, and we can dispose of the first stack. In fact, the move function automatically disposes of itself because we don't want to be adding new things to something that has already had everything moved out of it, essentially. So with this move function, we can essentially pull everything out, pass or use this new disposable stack in our async dispose function in our method that we've provided, where the user can dispose of these resources. But for all of the code leading up to that point, we're still protected essentially by this await using at the very top. We still have the ability to say whenever something goes wrong here, we're still going to clean everything up. And this is, when I discovered this, like when I saw this and sort of figured out this was how it was meant to be used, this was sort of one of those moments where it sort of really clicked on my brain how useful this whole sort of system is. I'm always impressed by the people who sort of come up with these APIs and design these sorts of systems, because, yeah, these sort of little bits are really useful. Anyway, that's my gushing part over where I tell you how great those people are, I hope. Yeah, so my last piece of advice really here, or the last thing that I want to talk about, I have called write programs as functions, and I'm not very happy with that slogan. If you have a better one, please come up to me afterwards. I'm not really sure. I'm going to give you an example, and I'm going to hope that that makes it clearer. Here we have a main function, the sort of function that would essentially run your application in a node server context. We create the resources, potentially using a setup function like we used before. We create a server, say, and I'm going to assume here that the create server also starts that server and sets it off running. I am a native English speaker, I promise you. But yeah, and then we are going to add events and things to handle different cases that can come up while we're running our code. In particular, the important one for us here is at some point, we want our server to be able to stop. We want to be able to close everything down. In this case, we'll listen to the SIGINT signal, and if that fires, if someone fires SIGINT, presses Control-C or whatever, then we'll dispose of all the resources and the server will shut down. This works, but the problem with this is that when we add new things in the first two lines, if we add new resources that we're creating, new elements there, then we also need to add them later on. We still need to mentally be thinking about managing our resources. We're not solving the problem that we had at the start. However, we can try and see our main function not just as a setup function, but as a function that runs for the entire length of our program. Essentially, our main function should be the program, and therefore when the main function quits, when we stop the main function, all of the resources can get cleaned up using the syntax. And an example of that is this. We have the using at the start, and we can create all the resources. And then essentially, we have a period where those, like the server is listening to incoming sockets, it is firing off events, it is passing things to request handlers, that is all sorted. What we want to do in this function is essentially wait for the moment where this function can be shut down. And we have that is whenever SIGINT occurs. And Node.js includes this once function, which handily does a lot of the work for us. And we essentially say, hey, whenever whenever the SIGINT signal is fired on the process object, then return or resolve this promise, and the function is over, and we automatically get everything disposed of. And this way of thinking about functions or about programs, trying to build them in such a way that functions are living for essentially the full length of time that the resources they are creating are living for, allows us to, like, when we mix that with this using syntax, we can make our lives a lot easier, at least in my experience. This is the experience that I've been having. So yeah, that was essentially what I wanted to tell you. Oh, no, very important. Can you actually use this? I mentioned at the start this is a proposal. The easy or the nice stuff is, can we use it in library, or is it used in libraries that we can actually use? Node.js, yes, it is used in a whole bunch of stuff, even on 18.x versions. If you know, like I am, are still using those. I'm trying not to, but it's taking work. And for all sorts of different things, like the classic things like files or processes or servers, where it's sort of a bit clearer what the resource there is that should be disposed. Timers, I used set interval earlier as an example. I didn't actually need to use set interval. We can clean it up much more easily. Or I didn't actually need to use the more complicated system that I did there. We can clean it up much more easily. But also things like mocking. If you write a test, you often have a after each function or something like that will clean up different things that you've been mocking at the end of the test. We can do that with symbol.dispose and the using system, and it just works automatically. So this is great. Third party, there's plenty of them. I didn't have a good picture, so I just searched on GitHub, and there's a lot of results. In my experience, there are often, this is something that is increasingly being added in the modules I'm using, which is great. So yeah, we can use this in libraries. That is the good news. The rest of this is less good news. Syntax support is currently not there in any engine, including V8. It is getting there. There is an issue that is being worked on. It should hopefully come soon, but it's not there yet. However, if you're using Babel or TypeScript already to transpile anything in your system, in your code, then TypeScript supports it straight out of the box. Babel supports it with a little bit of configuration, but it's very much part of the default ecosystem, or part of the Babel ecosystem, and very easy to add. Symbols, we need these well-known symbols, symbol.dispose and so on. Again, not implemented natively, but they are implemented essentially as a polyfill that already exists in Node. So if you use Node, you have access to them anyway, and that polyfill should be sufficiently close to the native version that you shouldn't run into any issues there. And then finally, the global objects, the sort of disposable stack and async disposable stack. Again, like with the rest of it, it's not quite there natively, but there are plenty of third-party polyfills. And I think what this basically means, like, if you're looking at the left-hand side and going, oh, that doesn't look great, then it's coming soon, and you should definitely wait and take your time. If you're looking at the right and you're thinking, oh, we're already doing half of that stuff anyway, then this is probably something that you can already start using and playing around with. This is stage 3 stuff. This is very firm on how it is going to behave. So there are very, very unlikely going to be any surprises coming in the future. So yeah, I was Jonathan. Thank you very much.